A point absorber is a wave energy converter that harnesses the relative motion between the steady seabed and the fluctuating sea surface. Many devices have been proposed meeting this general feature, and some of them have been validated in real environment. Hence, it is the way in which such feature is met, technically called the PTO as an acronym of power take-off, what distinguishes the different developments. Let's study the ESWave's PTO to understand not just its physical principle, but the fact that this technology is actually more proven than what you may think it is. The ESWave acts functionally as an inverted internal combustion engine. In a typical internal combustion engine, there is a steady block of cylinders containing pistons that reciprocate, driven by the combustion of a fuel. With the ESWave, this principle is inverted by anchoring the pistons to the seabed and allowing a block of cylinders solidarily linked to a buoy to reciprocate with waves. This facilitates the harnessing of the relative motion between the steady seabed and the fluctuating sea surface in the ESWave by the creation of relative pressure that can be conveyed to turbines and be transformed into electricity. The energy generation converts the ESWave into a point absorber within the wider classification of what are called wave energy converters. Coming back to the parallelism with an internal combustion engine, according to the Western producer, there are 1.4 billion internal combustion engine vehicles worldwide today. This means that an internal combustion engine is a very well proven technology. Now, from a technical perspective, internal combustion engines are made out of compression modules, which are in turn basically constituted by a piston and a cylinder. There are important differences with an internal combustion engine, though, which are worth looking into. As point 1, the speed of the block of cylinders reciprocation is much slower in the ESWave, which results in less heat being generated. The figure shows a normal internal combustion engine running only at 300 RPM, which is less than 3 times slower than in the idling process. On average, our ESWave reciprocates at 6 RPM, or some 150 times slower than the idle speed in a car. As point 2, the ESWave's chambers contain cold liquid rather than a chemical corrosive gas at a very high temperature. As point 3, the cylinders, as the only moving parts in the ESWave's compression modules, move vertically, which means that there is no conversion from the linear reciprocation of pistons to the circular rotation of the crankshaft. Now, it is easy to understand how the point absorber application the ESWave brings is nearly proven by understanding the analogies with the well-proven internal combustion engine.